followed by what subscriptions and resource groups are. After that, we'll cover our second learning objective on compute, where we'll talk about some of the different compute types in Azure, as well as some of the options on how you can host applications. Let's get started with our first learning objective on Azure architectural components. Azure regions represent a collection of data centers that provide flexibility and scale for your applications and services. These regions help preserve data residency, ensuring that your data stays within specific geographic boundaries as required by regulations or business needs. When selecting regions, it's important to choose the closest region to your users to help reduce latency and improve performance. Additionally, you should be aware of region deployment availability to ensure that the services you need are available in your preferred region. While most services are region-specific, there are also global services that are region-independent, such as Microsoft Entra ID. Global services provide consistent functionality regardless of the region where they're being used. Azure Availability Zones are physically separated data centers within an Azure region. Each availability zone includes one or more data centers equipped with independent power, cooling, and networking. This setup acts as an isolation boundary, ensuring that if one availability zone goes down, the others will continue working within that region. This design helps maintain high availability and resilience for your applications and services, minimizing the risk of downtime and ensuring business continuity in the event of a data center failure. Each Azure region is paired with another region that is at least 300 miles or 500 kilometers away from each other. This distance helps to mitigate the risk of natural disasters or other localized issues affecting both regions simultaneously. Some services provide automatic replication to the paired region, enhancing data redundancy and availability. In the event of an outage, recovery of one region is prioritized out of every pair, ensuring that services can be restored as quickly as possible. Additionally, Azure system updates are rolled out to paired regions sequentially, not at the same time, to minimize the impact on availability and ensure continuous service. Azure Government is a physically separated cloud service that meets the security and compliance needs of U.S. federal agencies, state and local governments, and their solution providers. It operates as a completely separate instance of Azure, ensuring that it's physically isolated from non-U.S. government deployments. This isolation helps maintain the highest levels of security and compliance. Additionally, Azure Government is physically accessible only to screened authorized personnel, which provides an extra layer of protection for sensitive government data and applications. Azure China is notable for being China's first foreign public cloud service provider in compliance with government regulations. It operates as a physically separated instance of Azure Cloud Services and is managed by 21VNet. This separation ensures that all data stays within China, maintaining compliance with local regulations and providing a secure and reliable cloud environment for businesses operating within China. Let's take a closer look at the Azure infrastructure around the world with a little demo. All right, so let's start off by going to, I think this is just a great tool to go and view what data centers look like all over the world. So we're going to go and look at this global map, right? So let me get this in here. It's datacenters.microsoft.com/globe/explore. Let me fix my typos here. Data centers. And what this is an interactive globe of what Azure basically looks like, around the planet. You can see, a lot of our cabling. We do have, one of the hugest networks in the world. It's all dark fiber, later across the planet. But you can see things like all the regions around the world, things like point of presence, stations. You actually see satellites in there as well. We do have Azure Space. And you can look at this. You can zoom in on different places and see a lot of it. So you can filter. So let's come down here. Let's remove everything and just add regions. There we go. And we can look at regions around the world. So Let's get back over to towards North America, for example. We can see all the various regions around the world. We can hover over top of them and get a little more information on them as well. So if we click on them, you can see this is West US 2. We see when it was opened, it supports availability zones like I just highlighted there. And it's pretty good. So let's add some other things here. We add all the networking components in here. You see things like edge zones, network point of presence, like POP environments. And these are really useful for things like, content delivery networks and all that. So you see that these are located in a lot more locations around the world. The idea is that we can have, things like caching environments actually be closer to the people that are going to consume that. So let's close that, right? And you can look at a lot of these environments and just play around with it. It's actually pretty amazing. We also have sustainability projects, right? Because one of the things that we're very big on in Microsoft here is to be carbon neutral. And so you see that we actually support a lot of these solar, wind farms, and all that to help supply power to Azure, because it's we got to run on power, and that's part of this map here, this interactive map as well. Let's see some other things. You can take a tour of some other things in here as well. Like if you want to look at the data center itself or Azure Space, you can actually go into some of those. The data center is a little more complex because you're going through the data center. So let's look at Azure Space. And I just love this view. So a lot of people don't know that Microsoft, we do have a space program. It's not, we're much more about communication and all that, but you can check that out and get a little blurb on it as well. So that's kind of neat. So let's go back to the globe. And yeah, pretty cool. All right, with that, let's go back to our presentation and continue on. Azure resources are the essential component that you use to build cloud solutions. These resources include storage, virtual machines, networks, and more. Storage allows you to save and manage data efficiently, while virtual machines provide the computing power needed to run application services. Networks enable communication between different resources, ensuring that your cloud solutions are connected and functional. By leveraging different resources, you can create scalable, reliable, and efficient cloud-based applications and services. Whenever we create a resource in Azure, we add it to what's called a resource group. A resource group is a way to manage and aggregate resources into a single unit. Resources can exist in only one resource group at a time, ensuring clear organization and management. Resources within the same resource group can be located in different regions, providing flexibility in deployments and management. Additionally, resources can be moved to different resource groups as needed, allowing for easy reorganization. Applications can also utilize resources from multiple resource groups, enabling better management and scalability of complex solutions. Azure subscriptions provide you with an authenticated and authorized access to Azure accounts. What this means is that whenever you access a resource in a subscription within Azure, you'll need to be authenticated by the tenant that the subscription belongs to, as well as authorized using the permission set within the subscription that manages the resource. Subscriptions also serve as a billing boundary, allowing you to generate separate billing reports and invoices for each subscription. This helps in managing costs and tracking expenses much more effectively. Additionally, an Azure subscription also acts as an access control boundary, enabling you to manage and control access to the resources within that subscription. An Azure tenant can have one or more subscriptions, providing flexibility in how you organize and manage your resources. Many organizations will use multiple subscriptions to control access and billing to different environments. For example, you might have 3 subscriptions for the same organization, broken down into production, test, and development subscriptions. This approach helps to isolate and manage environments much more effectively. Azure management groups are an effective way to organize and manage multiple Azure subscriptions. Management groups can include multiple subscriptions, allowing you to apply policies and access controls across all of them simultaneously. Subscriptions inherit the conditions applied to the management group, ensuring consistent governance and compliance. Azure supports up to 10,000 management groups in a single directory, providing extensive scalability for really large organizations. Additionally, a management group tree can support up to 6 levels of depth, enabling you to create a hierarchical structure that aligns with your organizational needs. Let's take a moment to do a demo on how to create a resource in Azure. All right, so in this demo, what we're going to do is we're going to open up portal.azure.com. I've already opened it up here, so just to point out that this is the URL that we're going to. And we're going to go and create a resource. It's pretty easy. So just click on create a resource, and we're going to create a virtual machine. I could create it right here, but I want to show you how to search for it. So that way we can find any resource. So I'm just going to type in virtual machine, right? Go ahead and continue through the search. And this will take us to the marketplace. Let's close that so we have a little more on the screen. And we can use this to go through a lot of resources, like 12,000 plus resources that are pinged for virtual machines. I want the Microsoft one, so this is this one right here. So let's create that. Now, when we're creating the virtual machine, this is where we get into creating a resource, and we start setting all of the settings for this resource in particular. So across the top, the networking and all that. So any resource, every resource really has to belong to a subscription, so we pay for it. We also want to put it in a resource group, so we're going to create a new one in this case because resources need to belong to resource groups so we can manage them and group them together. So let's give this a name. Let's say Azure Demo. Oh, I need to get rid of that space there. There we go. And click on OK. It should be good. Make that. And next, we're going to have to give this virtual machine a name. So let's go with something like my VM. And let's see. Yeah, we'll keep the dash in there. And then where do we want it, right? So what region around the world do we want it? And even if the resource group that it belongs to is somewhere, we don't have to put it in the same resource, in the same location as our resource group. So let's put this, how about, since I'm a little friendly with this area, let's go to Canada, with Canada Central. And then, there's a lot more settings after this, like availability options. Do we want to support availability zones? And where does this one want to live? What kind of virtual machine is it? So this image and, the architecture and everything. We're not going to go through all of the settings here. That's really for another course for another day. This is just really kind of to represent that, hey, yes, we can create a resource. Now, because we're making a virtual machine, we need to set the security on it. I'm going to, just so you know, for Windows and all that especially, we can go and put in the username and the password for that, that root user, or that in Windows, the admin user. So let's put in the super secret password, talking and typing at the same time. Hopefully these two match. There we go. It looks like they match. That's great. And for this one, we're going to take a lot of the defaults out of this. We could go through and set up like the disks and the networking, all that. So this looks great, I think. So the disk there, let's go and just make this one, right? So using a lot of the defaults. Okay, and also while this is creating, you would have noticed that there is the estimated monthly cost over here on the right-hand side. So you can kind of see from the settings, what this should roughly take. Now on the review and create page, this is really going to review it and validate everything I'm doing first, make sure I'm allowed to do it. And then we'll have to hit the create button to say, okay, yeah, that looks good. Now let's go and create it. Now this will take a tiny bit to create, not too long because it's a pretty small machine. But at this point, we're submitting the deployment over to the resource manager. The resource manager has accepted it at this point. The deployment's going on. So we're just watching this deployment go. And some resources go very, very fast. Some resources take a lot longer. Virtual machines, we do need to move images and all that. But there's a little more to virtual machines and I'm going to show you this in just a minute. All right, so as you can see, there's a lot of resources here. But this one should go fairly fast. And we'll look at these resources in just a minute. There we go. Okay, so this is done now. So let's go to this resource and see this, see what we created. So when we go here, we get the Azure view of this resource, and we can see we can connect to it. We can start working with this virtual machine. It's already started, and we can start really using it for this. So one of the things we want to show you is in the resource group. So if we open up the resource group, that's all I've done here is just to open up that Azure demo resource. We see our virtual machine, but we also see a bunch of other things. So like I said, virtual machines can't really exist without things like the IP address, that we use to connect to it, the network security groups to help secure it, the network that it needs to communicate on. So, so when we create this, a lot of those settings from the virtual machine were to go and create this, but it, if we leave it at the defaults, it's going to ensure that these are all created for us. So this works, including our disk. Looks good. So with that, let's jump back over to our presentation. Now, let's get into our next learning objective on Azure Compute. Azure Compute represents on-demand computing services that provide a variety of different types of computing resources and include things such as disks, processors, memory, networking, and operating systems. One of the core compute types are virtual machines, which allow you to create and manage virtualized environments. These virtual machines, or VMs, can run different operating systems and applications, providing flexibility and scalability for various workloads. Next, we have app services, which enable you to build, deploy, and scale web apps and APIs quickly. With app services, you can focus on your application code while Azure handles the infrastructure to host your web app, which provides high availability and security. Container instances are another example of Azure Compute Services. They allow you to run container-based applications without needing to manage the underlying virtual machines. This makes it easy to deploy and manage containerized applications, providing a fast and efficient way to run simple container-based workloads. Azure Kubernetes Services, or AKS for short, is a managed Kubernetes service that simplifies the deployment, management, and operations of Kubernetes clusters. AKS provides automated updates, monitoring, and scaling, making it easy to manage containerized applications at scale. And lastly, Azure Virtual Desktop offers a desktop and app virtualization service. It allows you to deliver a full Windows experience to users, providing secure and remote access to applications and desktops from any device, while hosting the underlying compute, all within Azure. Azure virtual machines are software emulations of physical computers. They include virtual processors, memory, storage, and networking, and provide the essential components needed to run applications and services, just like they're running on a physical server. As an infrastructure as a service-based service, Azure VMs give you total control and customization over your compute environment. You can configure the virtual hardware to meet your specific requirements, install and run any software you need, and manage the system as you would with a physical server. This flexibility makes Azure VMs an ideal solution for a wide range of use cases, from development and testing to running production workloads. Azure Virtual Machine scale sets provide a load balanced version of multiple virtual machines that can automatically scale in or out whenever needed. So when resources need to increase, the scale sets can scale out, adding more virtual machines to handle the additional load. Conversely, when the resource needs are lower, the scale sets can scale in, reducing the number of virtual machines, which in turn helps save on costs. This dynamic scaling ensures that your applications have the necessary resources to perform optimally while maintaining cost efficiency. Azure Virtual Machine availability sets ensure high availability for your applications by grouping virtual machines in a way that protects them from hardware failures and maintenance events. Update domains keep virtual machines grouped so they can be rebooted at the same time without causing an overall outage. This means that during planned maintenance, only a subset of your VMs will be rebooted, ensuring that your application remains available. Fault domains, on the other hand, group virtual machines based on common power and networking. This protects your VMs from hardware failures, since VMs in different fault domains are placed in different racks, each with its own power and network resources. By using availability sets, you can ensure that your applications are resilient and can withstand both planned and unplanned outages. Let's take a closer look at virtual machine scale sets with a demo. All right, so in this demo, what we're going to do is we're going to go and create a virtual machine scale set. And so we're just here in the Azure portal, but just to really emphasize that we can do things many different ways, I'm going to go do this with the Cloud Shell. So let's open this up, and we're going to provision our virtual machine scale set, everything that we need, and handle that mostly in here. So let's get a prompt in here. And I do have a lot of these commands already set up, so just to save you from watching me type. So I'm just going to go and grab those commands. The very first one is this one, group, AZ group create. So all that we're really doing is we're making this resource group, right? Called my resource group. It's going to be in Canada Central. It's very fast to make that, so we're already back to the prompt. And this next one, I'm going to grab the command here. We're going to create a virtual machine scale set, right? So VMSS create, and then it's just a lot of the settings for this. So my resource group, for where we're going to put it, we're going to call it my scale set. We're also going to have the admin user be Azure user, and we're going to make sure that it's located in Canada Central. So that's going to go. Now this will take a little bit. If you recall the earlier demo on virtual machines, the virtual machines, a virtual machine takes a little bit, but also has a bunch of other resources that are creating with it as well. So this is currently running. It needs to make all those resources. Virtual machine scale sets, just as a reminder, it's one or more machines. So we can have 2, 3, 10 virtual machines all working together to provide kind of that same compute, to handle a particular workload. So the real magic behind this is its ability to scale, and that's what we're going to do in a little bit. So this does take a little bit to go. Shouldn't be too bad. It's a relatively small machine here, so hopefully this gets created fairly quick. Virtual machine scale sets, they're really powerful because it has a load balancer built into it. So it's one endpoint that people consume to get it. Oh, there we go. So it didn't take too long. There's a virtual machine scale set created. And with that, we can see that the result of this, we see all of the settings that were created. So it's all the JSON coming back and say, hey, this is finished. Okay, so next we're going to go and configure the policy for auto scaling. So we're going to first create the policy, and this is AZ Monitor auto scale create, and this is really just to give some high level settings like. We're going to put this policy in the resource group. It's going to be for this particular resource. It's our virtual machine scale set name I just highlighted. It's going to be for a virtual machine scale set, and we're going to name it. Just name it auto scale, and then all of these properties are just going to be like the limits on auto scaling. So this isn't really doing the auto scaling. It's setting up this profile for it. So let's get this going. And then we'll be able to set some rules with this to turn around and actually specify how this is going to trigger. All right, so that's created. That goes really fast. You can see the results there. Now let's go and add 2 rules. We'll start off with a rule to scale out. So we're going to add more machines to this. So let me grab the command here. So here's this one. You notice it's auto scale rule create, right? So this is creating a rule. It's for the profile that we just set up. The name was auto scale. We just called it that. And then here's the rule: percentage CPU greater than 70 average, so 70% average over 5 minutes. And what we want to happen is to have that scale out with those extra 3 machines. So that scale out 3 was for that. So that's already done. You see the scale action right there. That last value is 3. So if we go over 70%, we'll add it. Now, the next one is we're creating a rule to scale in. So if things calm down, we're going to do that. So again, rule create. It's also targeting that same profile. The difference is that the rule is going to be say, hey, if things slow down, percentage CPU less than 30% average over 5 minutes, let's scale it in. Let's reduce the number of machines by 1. And it's going to calculate that, periodically and say, oh, now we should drop 1. Oh, now we should drop 1. And these rules go in pretty fast. So that's all done, with that. Now, the next part here, this is all done, right? We have auto scaling rules, so that virtual machine scale set will react to it. The next part is we want to go and provide some load to it. So what we're going to do is we're going to connect to virtual machine scale set. So I'm just going over to the resource group where we created it. I'm going to come down to the scale set itself. Let's open that up. We need to find out what its IP address is, for example, and then we're going to connect to it, and we're going to make those virtual machines do some stuff so we actually trigger the scaling. So here's the public address. We're going to grab that. We're going to need that. And we're going to go back over to the Cloud Shell here. And what we're going to do in the Cloud Shell is we're going to connect to that environment. So we're going to do a secure shell, because these are Linux-based machines in this case. So it's Azure user, that's our admin user, and then we're going to connect to that IP address that we just grabbed. And we're going to use port, this might seem a little unusual, but port 50,000 in here. Now, the load balancer in front of this just defaults to port range 50,000, and that port range will map to 22 in this case. So we're going to say, yep, let's connect to it. And we now have a shell to one of the machines that are in the virtual machine scale set. Now, this next part, we're just going to get it to do something. So I'm just going to grab a little bit of code. We're going to do an app install for an app called Stress. So it's simple. We're just making the virtual machine kind of do something to stress it out. So the CPU goes really high. So we just had to run that. One of the machines in here is currently, stressing out. It's slowly building a bunch of, right now it's installing packages, but it's going to drive the CPU up, right, for that. This is going to run. We do have more than one machine. So when we created this virtual machine scale set, we have 2 instances when you created it. So what we're going to do is we're going to connect to it again. And just because we just created it, these the ports that we're using is going to be sequential. So let's do a Cloud Shell. Let's make sure I grab that IP. Let's grab that Cloud Shell again. And oh yeah, this one's going. So let's make a new session. We don't want to disturb that one. And so for this, we're going to jump back in here. We are going to connect in the same way. We're going to do the same type of workload. The only difference is really we're going to use a different port number. Now, there is a way to go and look up what ports are being used, by the different instances. This changes because we just created. I know that the next one is actually going to be it's out of a range from 50,000 above, right? So it'll go 50,000, 50,001, 50,002, 3. So oh yeah, and I'm kind of jumping ahead. The 3 doesn't do that because we don't have that many machines. I was thinking we had a bigger one. So 50,001, just correct that, should give us the connection to the second machine, which it did. All right, so we're back and logged in here. We're going to do the same thing. We're going to install that stress application and get it running. So now we have both machines are going to spike their CPU. And hopefully what we should see is that our auto scale rules will actually apply. So we have those 2 instances, right? So if we check out the instances here, we should see our 2 instances and see that go. We can control scaling and everything here in the browser too. So the scaling's there. But yeah, there's our 2 instances. I'm jumping around a little bit here, but this is working away in the background. We just need to do it. Now we can monitor this a number of ways. So metrics, we can look at the CPU load that's on here. So when we're actually doing this real world, we do want to sit and monitor and see how these virtual machines react, from load and all that, so we can react appropriately. So I just changed this around really quick to percent CPU. This is the average for the scale set, so it's still really low. There's a little bit of a delay here, and those threads are just still spiking and all that. So, this would actually reflect those numbers pretty good. And so scaling, all the settings I mentioned before, the auto scale setting that we set is reflected there. So let's go back and let's look at the instances and see if we have the auto scaling operation happen. Now we should see this go from 2 machines to 5 machines, because we set this to add an additional 3. One thing about this view is this view doesn't refresh automatically. So if you're sitting here and staring at it, this will take some time to have this happen. But if you're sitting here and staring at it, even if the auto scaling actually took place, you would have to refresh this screen to get the update on the screen. That's by design, by the way. I get asked about this a lot. The reason is because that refresh process actually takes adds to the load in the background, because we got to pull all the information from it. So a lot of places in Azure just don't do automatic refreshes very intentionally. Anyway, so at this point we're just waiting. We did configure it to scale after 5 minutes of workload. We usually want to see that happen over a period of time. It's actually more accurate to do it. We're also doing this with only 2 machines and going to 5. A lot of the times when we do scale sets, we're typically working with larger, smaller machines with a larger number of nodes. So we can actually have scaling happen a little more smoothly, different times. Anyway, at this point, we're just waiting. And hopefully we see our scale set work. Now, just to speed things up, because I'm sure nobody wanted to watch this for 5 minutes, I actually have one of these. I triggered this earlier to make this scale. And so with that, hoping that we can see this a little bit faster. So eventually. All right, let's check this out. Let's hit the refresh. If I'm timing it right, hey, perfect. I got it right on. So you see that there's one still creating. I just happened to catch this, while it was still scaling. We see that we have an additional 3 nodes. We have 5 in total. 2 of them have already finished their startup. One is just finishing creating, and that's what we want to see. So, just triggering this a little early so we didn't have to wait really paid off here. We refresh again. Let's see if that other one finished. Yeah, there we go. You see, in this case, all 5 are up and running. All right, with that, let's go back to over to our presentation and continue on. Azure Virtual Desktop is a desktop and app virtualization service that runs in the cloud. It allows you to create a full desktop virtualization environment without having to run additional gateway servers. This simplifies the deployment process and reduces the risk of resources being left behind. For example, if we were to deploy an application to a user's laptop, the deployment is more complicated since we need physical access to the device. And on top of that, there's a chance that the laptop might become lost or stolen, effectively having the resource left behind, right? That's an example of that. Additionally, Azure Virtual Desktop supports true multi-session deployments, enabling multiple users to access the same virtual machine simultaneously, which can help reduce resource utilization while still providing a seamless experience to its users. Azure containers are lightweight, virtualized environments that don't require operating system management. Since these are smaller and lighter than virtual machines, it's much easier to implement changes on demand, like scaling more rapidly than virtual machines are able to. Azure Container Instances are a PaaS offering that runs a container or a group of containers in Azure, providing a simple and efficient way to deploy and manage containerized applications. Azure Container Apps are similar to container instances, but offer additional capabilities such as load balancing and scaling, making them ideal for applications that need to handle varying levels of traffic. Azure Kubernetes Service, or AKS, is an orchestration service for containers designed for distributed architectures and large volumes of containers. AKS simplifies the deployment, management, and operations of Kubernetes clusters, providing automated updates, monitoring, and scaling to ensure your containerized applications run smoothly and efficiently within the AKS cluster. Let's compare Azure Compute Services, starting with virtual machines. Azure Virtual Machines are software emulations of physical computers, providing virtual processors, memory, storage, and networking. They offer total control and customization, making them ideal for a wide range of use cases, from development and testing to running production workloads. Next, we have Azure Virtual Desktop, a desktop and app virtualization service that runs in the cloud. It allows you to create a full desktop virtualization environment for users. These can reduce the risk of resources being left behind and supports true multi-session deployments, enabling multiple users to access the same virtual machine simultaneously. And lastly, we have containers. Azure containers are lightweight, virtualized environments that do not require operating system management and can respond to changes on demand much more easily. Azure Container Instances are a PaaS offering that runs a container or a group of containers in Azure, providing a simple and efficient way to deploy and manage containerized applications. Azure Container Apps are similar to Container Instances but offer additional capabilities such as load balancing and scaling. Azure Kubernetes Service is a full orchestration service for containers, designed for distributed architectures and large volumes of containers. AKS simplifies the deployment management and operations of Kubernetes clusters, ensuring your containerized applications run smoothly and efficiently within an AKS cluster. Azure Functions are another compute option in Azure that is platform as a service based and can use serverless computing, allowing you to run event-driven code without managing server infrastructure. This approach can help to bring developers closer to business logic by abstracting away the underlying infrastructure. Also, whenever we refer to serverless computing, it doesn't mean that there aren't any servers. Rather, it typically refers to the ability to provision that compute very rapidly on demand, rather than provision the compute beforehand. The code in an Azure function is triggered by various events, such as HTTP requests, timers, or file uploads, and the infrastructure can scale instantly to meet demand. Since you only pay for the resources used, serverless-based functions can be very cost-effective to host. It's important to note that serverless computing requires a different mindset and isn't suitable for every scenario. That being said, with Azure Functions, you can focus on writing the code for your service, while Azure handles the infrastructure based on the events that trigger your functions. This makes it a highly efficient and scalable component for many solutions. Azure App Services is another compute option in Azure. Azure App Services provide a fully managed platform that allows you to build, deploy, and scale web apps and APIs quickly. It also supports a variety of programming languages, including .NET, .NET Core, Node.js, Java, Python, PHP. This PaaS-based service provides enterprise-grade performance, security, scaling, and compliance for hosting web-based applications, making it a reliable choice for developing and managing them. Similar to Azure Functions, with Azure App Services, you can focus on your application code, while Azure handles the infrastructure, providing a seamless and efficient development experience for web-based applications. This brings us to the end of our second session. In this session, we covered some of the core architectural components of Microsoft Azure, including how it aligns with managing your services within Azure. We also reviewed some of the different ways that compute is implemented within Azure, such as Azure Virtual Machines and container services. We also spent some time on comparing some of the compute options as well. With that, let's take a 10-minute break before we resume with Session 3, where we'll be covering Azure networking. Enjoy your break and see you soon.